Awesome. So I always say also that if you look back at this past Christmas, Quest 2 really won Christmas. They had over 650,000 installations from December 24th to 26th, and they were the top of both stores. And that really tells you how many devices were in the marketplace, were bought at Christmas, and how many were coming on. And we're going to see that even accelerate as this year goes on. So the next thing here, and this is kind of a preview that we haven't seen this yet, but to be announced on October 11th, so coming up only a couple weeks here, the Quest 2 Pro. And you guys, if you're interested, we can talk more about this, what we know about this device, what we don't know about this device. But overall, this is going to basically be kind of the next generation above the Quest 2. And it's not something that's going to replace it per se, not for everybody, because it's going to be a more expensive device. But it's also going to be more of a premium experience. But that doesn't preclude you from basically going out and buying that Quest 2 device for $400. And that's a complete standalone device. You don't need you don't need a gaming computer, you don't need anything else. Now you can actually add a gaming computer to it, and you can actually stream games if you're doing games that have more computational complexity to those guys. But the Quest 2 Pro is going to open up some pretty amazing features. Some of the things that we do know that's going to have is it's going to have eye and face tracking. So it's going to be able to see where your eyes are looking. It's going to see what your face is doing. So if you imagine the evolving metaverse where we're inside of these social experiences, your avatar is now going to have is going to be able to track where your eyes are looking and track what you're doing with your face. So it's going to have very good simulation. So the realistic aspects of what we can accomplish with these new devices. And again, this one's going to be a little more expensive. They haven't named the price point yet. We'll find out on the 11th most likely. And I'm going to guess it's going to be between $1,000 and $1,500, where the other one's $400. So still not as expensive as the HoloLens, which is $3,500. So still very much consumer focused, not industry focused purely. But again, really exciting technology coming out. There's a couple different competitors coming out now that are finally almost competitors. We're waiting on the Pico 4. That's also coming out. But my bets are placed on the Quest 2 Pro at this point in time. So more stuff about the physics engine. So there are two major ones that basically rule the marketplace. They are Unity and Unreal. Unity uses C# as the primary language. Unreal uses C++ as the primary language. The price point, once you make if you're making less than $100,000, Unity's free. If you're making less than $1 million, Unreal's free. However, once you basically hit the cap for Unreal, they want 5% of that market, 5% of your profits. Not something I would want to do at this point in time. But they also have two other plans. These are the ways that anyone who's sane should go. You can basically pay $40 per month for Unity once you're over that $100,000 threshold. So don't hesitate to grab it now. You probably won't, unless you get really successful, which I really hope you do. You won't have to be able to worry about that for a while. Now, Unity, I really think is the easiest one to learn. And it has a huge, large development community online. You can hop on over to YouTube, and you can look for Unity, how to move or shoot or make an object or all that kind of stuff. And 9 times out of 10, maybe even 9.9 times out of 10, you're going to find some sort of resource out there. Unreal, I can say, has a much steeper learning curve. It is slightly more, the potential is slightly more powerful because you're in C++, you're a little closer to the bare metal. However, it generally takes more to do in Unreal what you can do more easily in Unity. So for me, the winner is Unity, and that's the one that I focused on, and that's what I'm going to continue to focus on until I really have a strong case otherwise. So as I was saying, here's a couple games. If you don't think that Unity has a strong contention to basically make epic games, these are all made in. And that upper left-hand corner one, if you recognize that guy, that's Beat Saber. It's made $100 million so far. That is no Trump change, and I wish I'd gotten in on the ground floor of that particular one. But all of these games are basically made with the Unity platform. So super lots of potential. I'd say definitely look in this particular direction. So that's where we're going to focus today. So where do we want to start? So first thing we want to do is we want ideas for a game. Well, so I'm a space geek as well as a regular geek. So I thought, let's make something where we can basically have the planets, the sun, do a little bit of of rotational geometry, maybe do some other kind of fun game aspects, but kind of pretend like you're a giant walking in amongst the planets and be able to kind of get a perspective on how big they are, how far they are, how fast they potentially travel. And we can add lots more complexity to this than we have in starting tonight, but you'll have an excellent foundation for moving forward for this game and anything else. So first thing we got to do is let's get graphics. Now I do user experience and user design, but I'm not the guy who's going to go out and draw all these things. I'm not the artist who has the expertise to do all these things in programs like Blender. There's only so many hours in a day. We've got to focus on what we can. So what I do is I hop out to some place called the Unity Asset Store. So this is usually my first place I hop out to. And then I'm going to basically log into that guy. And then we're going to start looking for assets. Let's start, something with a solar system. Let's see what's in there. And wow, there are 74 results in there. And I found one pretty quickly, the Amazing Solar System, for a whopping $9. That would have taken me probably a couple hundred hours to figure out how to do all this stuff. So let's grab that guy. That's a well worth spent $9. So let's set up our Unity project. Where do we start with setting up that Unity project? Unity has done a really nice job in the last couple of versions, and they've created something called the Unity Hub. So the first thing we want to do is we want to basically go download Unity Hub. So what do we always do? We type the name, we type download. It comes up as the first link on there, where we grab the download for Windows or Mac or whatever you basically want to go with. And I installed that guy. So now let's explore the Unity Hub and kind of show what that offers to us. So the Unity Hub's pretty nice. I got set in dark mode because all the cool kids are in dark mode. There's a list of my projects. Here's a list of my installations. So there are different versions of Unity. Unity is prolific in the number of versions. So I usually stick with the latest or the close to latest. You also have a tab in here for Learn. So here's a bunch of resources after this talk. I encourage you to download this and kind of glance through the resources. They'll help you get started. And then they also have a community. So the community they give you a link to the blog and the answers, the forum. So there's a lot of things built right in. Let's hop up to the top. Let's start a new project. And you have a bunch of different templates, just like most things. So 3D is what we want to go with. We're going to go with the 3D URP. URP stands for Universal Render Pipeline, and that's just the newer flavor of the way that they've optimized. So URP is a little faster than the other one. There are some caveats, the reasons you might want to go with 3D, but we're going to do URP to kind of show you the latest and greatest in this particular talk. So we made a project called Solar System XR. And now let's explore Unity. So let's fire it up, load it up. Takes a couple minutes. I won't make you sit through that. In this presentation, I've video recorded everything because you never want to do a live presentation with Unity because some steps take 5 minutes, if not sometimes more. So I'm going to make Unity look like more performant than it's ever been before, but it's also going to make us not have to sit here in awkward silence for a while. So that is where we are. So what we want to do next is go to this very useful site, my blog, and I write blogs primarily for me so that I can remember how to basically go and reproduce steps like time and again. So here's an XR step-by-step setting up your Oculus Quest XR project. It's great to be able to shoot out a blog. Again, think of you as your primary audience. If no one ever else reads it, that's okay. If you use it as a resource, that's great. Here are the steps that we're going to go through. And they seem like a lot of steps, but it's really pretty straightforward. But again, I want to show you step by step that it's not really that complex. But as long as you understand and have a resource like this that kind of shows you the steps, it's pretty straightforward to go through this process. But we're going to go through it point by point in very much detail so that we take away any apprehension that anyone could have. It's always getting over that first being apprehensive about jumping into a new language or a new IDE or a new kind of paradigm of things. So this is, that's what these meetings are beautiful for. We see the tip of an iceberg, and then eventually, when we have a problem or something that we want to accomplish, we've seen the tips of those icebergs, and we can kind of drill deeper in. So just remember this when you want to drill in deeper. So let's start with number one. We're going to basically make a change the UI to kind of a different lane. You have lots of different options in here. So we click on Windows, and this is just my preference. You can have whatever preference you like. But then I go to wide. And I just want to show you how I got here so that you didn't see what we were walking through and then go, oh, how did you get there? So in here, you'll see that we have several different windows. We're going to kind of show those off. And this is it's a very nice interface. They've done a great job with this, and they're very consistent. So if we scroll up, that's the scene tab. And that's the scene window is basically, it kind of gives you a visualization of all your objects. Now the game, when you switch to the game tab, that's what the player will see through what we're going to tell you later is the camera. The hierarchy is the list of all your objects in your scene, including the main camera that you're kind of seeing there. And when you click on those objects, the right-hand panel becomes your properties, essentially. So that's all the properties for the camera. Project, think of that as your file explorer, and that those are files explorers. And then the project search bar that you type in there, and basically the easiest way for you to find a lot of stuff in your project. So now we're going to hop on to basically creating a new scene. So in our project, we right-click and we say create scene. And then we name it what we want to name it. In this particular case, I'm going to name it solar system. And then if I click on that project or that scene, it shows up the hierarchy window. So now in the hierarchy window, we're going to delete the main camera because we're going to replace it with more of a VR camera. So we're just cleaning up our scene, doing a little bit of housework here. So delete that guy. That's good. Now we're going to basically go to our build settings. So Unity can build for a bunch of different environments. We want to build we don't want to build for the default window one. We want to build for Android because the operating system that's inside of the Quests is an Android operating system. So we click on switch platform. This usually takes 5 minutes, but welcome to the world of Magic TV. It goes much quicker. And then we want to add our open scene so that when we build the project and show it, it's the first one that shows up. Think of these as levels in your game. And then we can remove the one that we're never going to use again, just again to keep things clean. Close that guy. Next, we're going to now we're going to do the project setting. The one I just redacted there doesn't need to be done anymore in the version, so I kind of commented out. So we go to edit. We go to project settings. We're going to go to our player settings. First here, I'd say change the name of your company. That's pretty straightforward. We're going to go over to XR plugin management. This is where we're installing all of the XR SDK libraries under the scenes. And we can talk a little bit more about this later, but we're going to select Oculus. But everything uses, this library uses OpenXR as the underlying platform. OpenXR is something that allows us to write one application that we could potentially deploy to a bunch of different VR headsets. We're going to focus again on the Quest. So we're going to select Quest in both these cases. Then we're going to close that guy. Hey, look at that. We're getting there. All right, now we're going to go to our package manager. This is pretty similar if you do other IDEs. This again is how you bring in more code or more assets. So we want to go to My Assets. And then we're going to search for something. So Oculus integration, again, is an SDK that we want to basically import at this point in time, and that's going to give us a lot of functionality, like we'll see a lot of that when we talk about the controllers. And then you click on import, and it brings all those files in your project. So that wasn't too bad. And this real quick, there's a couple little dialog boxes that all you want to answer is yes and reset and yes and reset. Here's one saying we want to use OpenXR. I just want to make sure that as you go through these projects yourself, that you understand that these are going to come up. No big deal. Happens all the time. And basically it's choosing, it's giving you options, but you always want to say yes, essentially. I think we got one more after this. In actuality, it's probably take you about 5 to 10 minutes, as it took us only a couple there. Next one, now we want to go add our special camera. So we go to our project, again, kind of our file explorer. We type OVR camera rig, and then you can just drag it from there into your hierarchy. And now we have the camera rig that we want to basically use to see things. And now we want to add a cube. Let's do actually something. Let's put something actually in our experience that we can do. So you right click, go to 3D objects and click on cube. Now we have a cube in our experience. And you can see the cube in there. And now you can take those little arrows, you can drag it around, you've seen, it's very visual IDE. You can do things either visually, manually, or you can do things, all the same things that you're doing here, we can do through code. But this is certainly a simple way to start out. Now, if we look at our game, you can kind of see the cube. But I want the cube to kind of be an angle. So we go up to the right-hand corner, again, our properties, and we can easily change the rotation. So this, again, these are Euler angles, so 0 to 360. So we just kind of tip the cube 45, 45. Now, if we press play, let's see what it looks like. Now, if I had my headset on, it knows where my head is as I'm moving around because it's got sensors in there. And this cube looks perfectly stable in my experience. And we've made our first game. It's not a great game. It's not a great experience, but you have officially made the cube game. So congratulations. You've unlocked your achievement. Now everybody who's here is potentially an XR developer. You know the steps to get there. Congratulations, you've chosen the right path moving forward. So here's your reward. So do you remember back when you're a little kid? Don't sit too close to the TV, you'll ruin your eyes. And then now, isn't it awesome? It's like a TV right on your face. I love that one. Okay, now let's set up the world. Let's create the universe. That's a small thing to do while in this presentation. So next thing we want to do is we're going to go back to the Unity Asset Store. Let's go look for a couple other things. Let's look for the background. They call those skyboxes. Let's look for one that looks like space. So there's a lot of options here. This is the one that I found that I liked. Again, free is an excellent price, so free is always a good place to start. And then how we have to apply it. It's really easy. We go back to our package manager. Now we want to bring in those assets that we downloaded. So let's bring in that background. Click on import. There you see the files that it plans on importing. And then before we get out of here, let's go add the other assets that we bought. Here's our solar system, amazing solar system. Let's import that guy into our project. And now we have all the files, for the most part, until later, that we need to get started with this. Okay, let's close that guy and let's see where they are in our project. So make that a little bigger, scroll down here, click on, oh, there we go. So there's the amazing solar system. And you'll see in here they have what's called prefab. So that's already put together planets. So they've got the shape, they've got the materials, which i.e. the kind of the patterns on there, they've got the colors going for them. So those are literally good to go. So those are great. You'll also see in there things like, sometimes animations. And then here's our other things. Here's our diverse space material. So this is our background. So if we switch to our scene, there's our cube. We can literally just drag that background in there. Wow, what a difference that makes. Now let's I think we're going to run this guy next. And what we have here, for all you Muppet fans, is Cube in Space. Nice. So that's pretty amazing. That's actually, it's like the Borg all over again. All right, let's keep going here. So let's set up the world. Let's set up an Earth. So the cube's great. We're gonna do a little better in the cube. So we're gonna basically, you check that checkbox, the cube goes away, we deactivate it essentially. And let's go back to the prefabs that we looked at. Let's grab the Earth. All you have to do literally is just drag the Earth into space. How simple. You click on the Earth, you see there that you can kind of drag it around, do the things you want. Let's do a little bit of house cleaning here. I usually like to rename my scenes folder _scene so it rises to the top. Let's create another folder. We're gonna name that one scripts. Again, scripts, scenes, those ones are really good to have at the top. One more folder. Prefabs. Not prefabs, prefabs. So now we've got, those are the three folders that we generally play around with. So let's add a script. And this is really where we start showing how easy it is to code this guy. So we want to make the Earth do something. Let's make it rotate. That's pretty awesome for a solar system. Let's start that up. So you click on that script and it takes you to my favorite code editor, Visual Studio. And then we can start adding a couple lines here that do have a lot of power. So we want to add the rotation speed, and that's just going to be a float. By making it public, you'll see later that makes it so it shows up as an editable parameter in our user experience back in Unity. And we want to take the transform, basically transform basically refers to the object, and then we want to basically call a command. They already have one, they're called rotate. And then we want to tell it the rotate method has, the first parameter is the axis on which it rotates and how fast it rotates. So vector 3, consider that as an X, Y, and Z basically construct. And let me pause it here for 1 second as soon as I'm done there. All right, so let's look at this for a second together. So we have
a question also.
Yeah, fire away.
Yeah, so Andrew is asking how much would be missing out if we try to make XR rig work without OVR camera rig?
So it wouldn't work at all. Well, yeah, it wouldn't work at all because there are going to be specific things in there that allow us to view things for the VR setting as opposed to kind of just a three-dimensional PC game. And there are a couple different options you can do besides the OVR camera rig, but that one puts a lot of already completed code basically at our beck and call. Does that make sense? We can talk more about it too. People feel free to, by the way, anybody at any point in time, please feel free to contact me, whether it's by email, whether it's by Skype, whether it's by Discord. I'll share all of that stuff with you guys. And I'm a resource for you guys moving forward. I want everybody to be very successful with this stuff. So that's a great question. There are a couple of different, like the simple answer is it gives us a lot of power that's already done, that if we wanted to keep the main camera, we would have to do a lot of different configurations to basically make that camera and give it the same amount of power that the OVR camera already has. So I wouldn't do anything else at this point in time. All right, so let's talk really quick about this script. It's not a terribly complex script from what you see, but it's actually pretty powerful. So we pass on the rotation speed, and by, like I said, by making it a public float, that allows us to have that value as editable in the UI, and we'll show that again here in a second. And then what we're doing is there are two methods in here. There's a start method and an update method. The start method gets, like it says there, gets called once. It gets called before the first update frame happens. So that's where you want to do your initialization of code. That's where you want to basically set things up that you don't need to have called every time. Now the update method is called once per frame. There could be a lot of frames. We're going to be hitting this 30 to 60 times or more per second. If your frame rate gets too low, then in the experience, it gets a little bit jerky, and the players can feel that. And that's one of the leading contenders to basically having VR sickness, because you're not moving in the same speed that your brain processing and moving your head. So we want to keep everything in the update methods as pretty much streamlined as possible. But there's, again, a lot of things we can do in there. In this particular case, every single frame, we're starting to rotate that Earth, in this case, or whatever object we attach this rotate script to. And it's like I said, the first parameter in there is your vector. And again, I said vector is just, think of it as your XYZ coordinates. In this particular case, so we want to rotate, we put rotation speed in the Y position because we want it to basically rotate around its Y axis. Again, can we get more complex with this? Can we basically tilt things on their axis like planets actually are? Absolutely. You can do that stuff. But this, again, let's keep it simple. And then what I wanted to pause here for a second and talk is time.delta time. If anyone's ever played a old game on a faster PC, I used to love a game called Mech Warrior. And I had it on my old x86 EGA laptop from when I was in college. And then I moved it to a 386 laptop. And they did not have it timed well. So all of a sudden, the robots that were kind of plodding along on my old system literally moved faster than I can actually watch. It would go bloop, dead, bloop, dead, bloop, dead. And what they weren't doing there is they weren't taking into consideration the actual change in time between frames, for example. So that's why we multiply that rotation speed, or that vector, by the time.delta time, because that's going to say if we're a little bit slower, if one frame took longer than another frame, we want to basically still make it look like it's rotating smoothly. So that's the trick to basically make that happen. So that's pretty important. So that's why I wanted to pause there. So let's set up, what about the moon? Well, we got the Earth now. The Earth's pretty awesome. It's pretty bitchin'. So let's do something else. We go right back into our prefabs. Let's go grab the moon. That's a pretty big moon. I don't think it should be that big. How do we change that? Same way we change the rotation on the cube. We just hop up there, and now we change the scale of it. And I actually had to look these things up. This was fun. I looked these things up as we went. So the scale of the moon is about 1/4. So now all we had to do is grab that rotation script like we did before, and we basically plopped it on the moon. Let me go back there for 1 second. So when I brought the rotation script, oops, let me go back a little bit further. When I put that rotation script there, look at that parameter. So this was that public value that I called rotation speed. We can now, for every object you basically drag it onto, we can set that rotation speed to be whatever we want. So we assume that different planets rotate at different speeds, different objects in our universe rotate at different speeds. So now we have the ability with one script and a configurable parameter, everything we drop it on, we can configure that for that particular object. And again, I want to emphasize, this is a way to do in the UI. You can do this all in code and script when you get more complex games. So let's keep going here. So now I've done that, but that's nice. That's pretty cool. But we don't want the moon just rotating by itself. We want it to orbit around the Earth. So let's make one more script here. Click on that orbit. It's going to bring up Visual Studio once again. Our start and update methods. And we're going to focus on what we want as parameters for this particular one. So we want to have some sort of speed again. How fast does it orbit around something? And then the other important thing is, what does it orbit around? Everything is considered a game object in this particular case because of the basis of these basically being game engines. So we want to basically have game object and then rotate around. And so whatever rotates around, in this particular case, obviously we're going to make the moon rotate around the Earth. So again, transform, which kind of refers to our object. And there actually is already a rotate around method. Super cool. I don't have to write anything again. And in this particular one, we'll see what the parameters are. So there's our we're going to basically say, what is that object? So here's our rotate around, transform in position. Again, the position in this particular case is the XYZ coordinate of the game object that we're passing in that we wanted to rotate around. And again, here is the direction that we wanted to rotate. So we wanted to rotate around it in the Y, around the Y axis. Then we obviously have to pass our speed. So this is the third parameter. So we want to do the rotation speed, again, times our time delta time. So that's pretty easy to do. Now we go the same way that we basically applied the rotate script. We grab that orbit script and then drag that orbit script down onto our moon. And in here, you can actually drag objects into those blanks. So we wanted to rotate around the Earth, so we drag the Earth game object there, and we wanted to rotate it at speed 5. And again, that can be anything. This is the fun thing, is you can play with those speeds. You can make it go super fast. But here's the Earth. It's spinning. Hey, there's the moon coming around. And I noted by making the rotation speed and then setting the distance, you had a pretty good way of, and there are some more orbital mechanics going in here that you have to make it, because obviously the moon is locked to the Earth in the way that it orbits, so that one face is always facing us. So again, more orbital mechanics, we'll be able to do lots of that kind of stuff. Is there another question? I can pause right now. No? I'll keep going.
No.
All right. Oh, was question?
No, it's all good.
Okay, cool. All right, so let's set up the rest of the planets. Think of this as, I did this at 10 times speed, because think of this as like the Rocky Balboa going through all of his training. They kind of speed things up. So we're going to do this at 10 times speed. So first things we're going to do is we're going to basically bring in all of our other game objects, all of our other prefabs. We got the sun, we got Venus, we got Earth, we got Mars, we got all of those guys. Then I went and looked up here. Let me pause it for 1 second. Going too fast. There we go. I went and looked up planetary sizes, and then I kind of figured out that if I have Earth at a scale of 1 and the moon at a scale of 1/4, I had to go through and figure out all of the other kind of relative sizes of the planets. And again, we got 9 times, 4 times, 11 times. And seeing these things, as you kind of put them into perspective, it's really cool to see how small Earth is really compared to a lot of these places, to a lot of these other planets. So then I had to go figure out what size the sun was. Let me go pause that again. So the sun is 109 times wider than the Earth. That is huge. And that's a nice thing about this particular thing, is I started getting perspectives on the solar system that I didn't have before I started setting this up. That is huge. And then I started basically placing them in a line. Again, that's not relative to the actual distance. I kind of just want to say that, put them in orbits so that I can kind of see them all together. But you could then afterwards go back and put them all at their actual relative distances. And that's part of the game. And then here we started, and we applied that same orbit script to all of those prefabs. And then we made them all orbit around the sun. So the moon's rotating around the Earth, and the Earth is rotating around the sun, and it all just works. All right, now that's great. We can start running. We can watch it go. It's pretty amazing. But we want to be able to do something in this particular thing. No, you don't want a game that you just watch. So we want to start adding controllers. And again, this is where, if you had to code this from scratch, it would take you months, possibly. It would certainly take me months to probably figure out all of the ins and outs on how to do this. So this is a lot of the power that we get from adding those STKs. So again, back to my handy dandy blog, where I write instructions for who? Me, to remember how to do these things. So here's setting up your touch controllers. I scroll down, and basically every one of these blogs, just real quick. Every one of my blogs, I have kind of a summary at the top, and then I do a, forget that. And then I do a detailed picture by picture afterwards. So, oops. Oh, I think I went to the next slide. Una momento. That's what I get for pausing stuff. Okay, so we go back here. There's the blog. Scroll down, see the instructions. And now we're ready to go to the next one. So that's where that one ended. All right, so now what we want to do is we basically have those steps. What are those steps? Well, if we look at our OVR camera rig, say, here's again some of the stuff that you get for free. Here's your left-hand anchor and your right-hand anchor. We then want to go and start putting already pre-configured controller scripts in there again, things that Lance doesn't want to have to write. So I drag one down to my left hand, and I drag one down to my right hand. And then I click on one of those guys, the OVR controller, and I see all the properties on the right-hand side. The only thing I really need to set is that this one's the left one, and that this one is the right one. There, I have controllers already done. Graphics are assigned to them and everything. So if I click on play, all I have to do, there goes my planets, is I hold my controllers up in front of me. Look at that. Controllers in space. So that was a very little bit of code, almost none, that we basically had to put in there to actually get full controller tracking, utilizing all of the sensors on the Quest, utilizing all of the internal sensors in the controllers. We have IMUs in there, so we have accelerometers and magnetometers and all that kind of stuff that allow me to basically get full controller tracking for almost no code. So what are we going to do? Coding our controllers, aka, are you trying to push my buttons? So back to the blog. I have another post on this particular one. And in there, there's a script, C# script. I can click on there, and all this guy's doing is basically saying when I click on these different controllers, these different buttons, I get an event that I can basically map to. So let's hop back into this particular place. Go back to my scripts, and let's create another script. And we will call it controllers. I'm very descriptive. Click on that guy, open up Visual Studio once more. Copy and paste some code in there. So there is, real quick, that is all the game objects for, let me go back 1 second here. That's all the game objects that I want to basically draw. I'm going to drag all of those guys into here so we have access to all of those guys, which are all of the planets we have in the moon. And then we go down to the update method and we paste in that script from the website. All this guy is basically doing is saying we have the input, which is the controller. We get the down event of button 1 on the right controller. And that corresponds, button 1 on the right controller corresponds to A button. Button 2 on the right controller corresponds to B button. Primary index trigger is the trigger, and so on and so forth. And so we have 6 different ones there, A and B, X and Y, and the 2 triggers. I save that guy, I come back in here, and let's run it. We'll watch the debug menu as I basically press some buttons. So, pressing my buttons. Pressing my own buttons. So, if you look at the console there, you see A button, B button, right trigger. So it's working. Hey, I like it when it works. X button. So awesome. So we've got that working. So we've tested the minimal case that my controllers are tracking, my controllers are working, and now we can start coding those guys. So let's coding to control the heavens. So let's make it when we press the A button that it recenters all of our planets. And like I said, when I did remember I showed you guys that how I was dragging those guys out and setting all their properties. And then I said, we can do that same thing in code, and this is how you do it in code. You take that sun game object, the transform position. The position is its XYZ coordinates in space. And then I basically set that to a vector XYZ coordinates. The sun is the center of the solar system. So I made the sun the center of our game. And you'll see that Mercury is at 140, 160, 170, and so on and so forth as we go through the different game, as we go through different planets. Save that guy. Then when I go back here, when I start the game, remember I have that orbit script, so they start moving. But now when I press the button, they snap back to that position and they start going again. So we've made a way that we can basically manipulate the planets. So let's do something interesting now. We got the planets moving, but more interesting actually. So we've got the planets moving around. We have the sun there. We've got some orbital mechanics going on. Let's make it interesting. Let's make some asteroids. So there is another asteroid prefab in there. So we just drag that into our scene, and then we want to make a shoot method. So now we're getting a little more complex, but really not so much. So I just changed the scale of the asteroid to be pretty small compared to the planets. And then I want to basically we have to do a couple things if we want these objects, this physics engine to basically, pause as we go through here. If we want the physics engine to utilize all the powers of it, we can have collisions, and we can have all kinds of interactions that, again, that we don't have to program very much for. So what you start with is you make a game object into a rigid body. So this basically means that this object has the potential to interact with other objects in your space. You'll note here it's got things like mass, drag, angular drag, whether it's using gravity or not. We're going to turn off gravity here in a second, because if we didn't have gravity turned off, the game interprets gravity as down. And so you'd shoot an asteroid and it would just literally fall down. So we want the asteroid to basically shoot off and keep going as far as it possibly can in the game experience. But you can see here, you got a lot of pretty complex physics engine. That's why I call it the physics engine properties here that you don't have to, again, do a lot of complex mathematics to basically make work for you. Let's see here. There we go. Keep going. So we're going to turn off gravity. Now we're going to basically make the shoot script. So in this shoot script, we want to say how fast does that object say. And what we didn't do before, we didn't set a default value for those guys. So it's 0 by default. So this is on to give you another example, is you can default these scripts that have a default value. So in this particular case, by default, it's going to move at 2. And so in here, we want to do something very similar. In the update, we want to basically change the position every frame. So we do plus equals, because we want to basically keep adding so it goes in a straight line. Time to delta time times the speed times, and this is the way we're telling it what direction to go. So transform forward. So forward from where we're basically shooting. So it's going to go in whatever the direction that it was initially started, and it's going to keep going in that particular. So we've added a little bit more to our controller class here, and I have all this code on GitHub too, by the way. And now we're going to add a couple more things in here. We're going to add the tracking space and the object to instantiate. So what we're going to do afterwards is we're going to basically, the object to instantiate, which basically just is a fancy word for creating something, is we're going to basically have that asteroid as the object to instantiate. And the tracking space is a reference to the tracking space, basically where our controllers are. So you'll see that in here in a second. I gave myself a time to pause to speak, but I paused. So there's a lot of power in here. So let's write a method now to instantiate that asteroid. Thank goodness for spell checkers and Visual Studio. And what I want to pass into this instantiate is I want to pass in the controller, because I want to shoot it with my right hand. I want it to come out of the right controller. When I shoot it with my left hand, I want it to come out of the left controller. And again, this looks long, but it's actually really simple. So what we're doing here is we want to basically get the position and the rotation of each of those controllers. So there's already some methods in there, like you can see, it's tracking space, which is where we're tracking it from. Transform point, and then we're calling what you pass to that is your OVR input, get local controller position. So now I can basically do that. I know where the controller is, the left controller and the right controller are. And then the next line is again almost exactly the same, but it's basically getting the rotation. So we now know the rotation of how that controller is basically oriented in space, or oriented in our experience in space. So I'm going through that again. Transform. And again, a lot of this code is already done in there, but you do have to figure out how to put it together. The one thing I always do, and I'll do here in a second, is I always, for angles, I always find it easier to understand Euler angles. So if you basically put a parameter on the end for Euler angles, so that's the 0 to 1, or 0 to 360 angles. And then we just need to basically instantiate that object. So we call a new object. We pass it the object that we want to create. We pass it the position of the controller, and we pass it the rotation of the controller. So if we didn't have that shoot method on the asteroid, wherever we held our controller and we pulled the trigger, it would actually just appear there and stay there. And right now, what we're going to be doing here is we're going to go down to our right trigger, and we're going to say, here, instantiate this object for our right controller. And then we're going to go down to the same thing for our left controller, and instantiate that object for our left controller. Again, pretty straightforward. It takes a little while to figure out all these scripts and how they all fit together. That's why I like to document it for everybody, so that you don't have to go through all the same pain to find this stuff out that I did. All right, so animations and sound. In space, they can't hear you scream, but in our game, they can. So let's go back to my favorite place, the Unity Asset Store. Again, free stuff is lovely. You can just type in free explosion, and this is looking for some animations because we want to basically have an animation as it hits it. And there are tons of good ones in there. This was one I found and I just started with, and I found one that I want to go, which is that kind of like red explosion. Then we want to do something else. We want to go get some sounds. So we got our explosions. Now let's go with free sounds. And there you go. There's a free sound effect pack. There's an explosion sound effect in there that I found that I liked. I downloaded a couple, and that was my favorite. And then here's a real quick snippet of code that I wanted to walk through. So so we have that update method that we had before. It's the same thing. This is in the shoot class. So we do the transform to position, and we basically add a certain amount every single time that update's called, so that it moves away from your controller. Now what we're doing is we're doing it on collision enter. That allows us to basically detect when a rigid body impacts something. One thing that we kind of skipped, but I want to show you really quickly, is that when we did all of that setup in our training montage, I tagged everything with the tag of planet. All of those bodies were called planets. You could tag them. You could have a bunch of different tags if you want to basically have collisions do different things with different impacts. Maybe you have aliens. Maybe you have little alien ships in there, and you can shoot the alien ships. But in this particular case, I say if collision.collider.tag was planet, then I want to do what's in this particular block of code after that. I could always have another one. If collision.collider.tag equals alien, maybe I would do something else. I always like writing a little messages to myself in the debugger log, and then I instantiate, instead of instantiating the asteroid like we've done before. Now all I have to do is instantiate the explosion. So that animation that we downloaded, brought into our project, I have that in that explosion. We have it at that position of where the asteroid is at that point in time, because again, this script's attached to the asteroid. And then we have the rotation of the asteroid. The explosions really don't really matter too much in the rotation, but it's still okay. And then this is really cool. All we need to do for the audio, there's audio that if you didn't have something when you have VR, when you have a three-dimensional experience, you have the potential to have three-dimensional sound. You don't want everything coming like right in front of you, all the explosions sounding exactly the same. So what we can do is we can basically tag that sound to appear at a position. So wherever that asteroid is, when it collides with our planet, i.e. things tagged planet, we want the sound to come from there. So if it's further away, we want it further away. If it's really close, we want it really close. If it's on my right, I want it on my right. If it's on my left, I want it on my left. So one line of code. Audio source, play clip at point. And again, this gives me that three-dimensionality. And then I pass in that audio clip, and then I pass in the position of this particular game object. And then the last thing I do is I destroy the asteroid, because I want that asteroid to look like it broke up and exploded in space. With these 3 lines of code, essentially, I've made an explosion, played the sound, that destroyed the object. So here we go. This is the grand finale. I've got all of the objects moving in space. I don't have sound on here because I didn't record it. But look at that. There's our asteroids. Just imagine boom, 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 boom. And see how they're rigid bodies and they have somewhat equal mass? They're actually moving Jupiter. That would be very unfortunate for Jupiter and very unfortunate for our entire solar system. But you can actually, again, if you wanted to, set the mass of Jupiter to actually the mass of Jupiter, and those asteroids aren't ever going to move it. But do you guys, hopefully everyone saw the NASA DART, where they collided an asteroid or they collided a spaceship basically into an asteroid to see how it moves. This is the asteroid's revenge on our planets. It's a very bad day. Did you guys see, by the way, at the very end there was a little explosion far off on Saturn. It says it took it a long time to get there. So that's it. That was I hope you understand how easy that was to get to that point. So a couple of small things else. Again, please take note of my blog. I write all these blog articles. I love doing this, and I love getting people saying, wow, that was pretty easy to get there, and it's a great resource. And if you find out that it's missing something, or it's not clear, or there's something you want me to blog about that you don't maybe know how to do and you want me to figure it out, let me know and I'll do it. I do want to hop over. There's one more thing here. So if you go to my blog, over the summer, I did a hands-on building an XR game. So if you head over to my blog, here is an entire lab that walks you through step by step through all of those articles plus some more that will walk you through creating these games. A couple ones that I want to point out here. Let's see here. Here's a couple helpful asset packages that you can put in that I didn't talk about. Like there's an auto save package. Unity does, since it's a complex program, does have a tendency to sometimes crash and at the most inopportune times. And if you don't save your code before it crashes, you're going to lose some stuff and you're going to swear. It's not going to be a great day. And I hate redoing things again and again. So there's an autosave one that every time you push play, it autosaves your project. And that's one I love in there. Another really cool one is this is where mixed reality pass-through. So pass-through is the ability for us to start taking our VR headset and making it into more of an AR or MR headset. We can actually take what's on this device, on the Quest 2, are black and white cameras, IR cameras as well, that they put on there for tracking the controllers. But they had the good idea, and they made it super easy for us as developers to allow us to, as developers, be able to use those cameras to show the real world around us and then render objects inside that space. So now we have that augmented reality experience or mixed reality experience. So a couple simple steps. Again, this was not easy to figure out how to do initially. And I was very proud that we were one of the first people that started actually publishing on this stuff. But this allows you to basically set up that mixed reality experience. And that is super powerful. So that is there. And again, I would just encourage you to go through those labs. If you want to take the next step with that, go through that lab, and you can get a game working where you're shooting stuff kind of in a similar fashion to this particular one. It does go over some additional features, and it goes over them in a obviously in a much easier to follow than just kind of trying to follow me in this presentation. So that's it. I hope you guys have enjoyed this, and I hope that you're all encouraged to go get a Quest if you don't own a Quest currently. If you do want to buy a Quest, let me know. I have every developer who does this stuff has a code, and if you use the code, both you and I get like a credit for the store. So I've not taken nearly as good advantage of that as I should have in the past. I could have had a lot more credits, but it gives you an advantage. So 400 for a $400 device, this is something that is super impactful. And I know I wrap this in the context of a game, but you can use this to build experiences for your work, for your job, for new jobs. This again we do this for a lot of different clients. If you guys know Andrew, who's on the phone here, we're doing some fantastically cool stuff using the HoloLens and Unity to perform neurosurgery. Neurosurgeons are going to use the device to literally align scans and operate on live people. And that's what we're doing. And this stuff really will change the world. And I really hope that this gives you the opportunity to say, I want to be in this particular space. But I'm here as a resource, and now I'm handing back to our excellent person basically in charge of all that. So thank you very much for giving me your time. And I had a lovely time with you guys, and I'm open to any questions.
Thank you, Lance. This was really wonderful. I'm all popped up to try out.
Damn straight.
Yeah. Guys, please post your questions, raise hand.
And if you have questions later, again, email me, contact me, get in contact. I am here as a resource. I want to see everybody succeed in this space. So I assume no more questions, or at least no more questions at this point in time. Everyone's overwhelmed by awesomeness.
Yeah. So how long you have been doing this, Lance?
Good question. Oh, you're very welcome, by the way, anonymous attendee. I've been doing this since the first HoloLens came out, which, again, it wasn't very many years ago. I want to say it's like 7 years ago. It really seems like we've been doing it forever, but it's really not been nearly as long as we think it has. But I've got boxes of old VR headsets down here. We spend our blood and tears and paychecks to basically keep up with all the different generations of technology. And it pays off, because that's what keeps us on the edge, and that's hopefully where I can basically go through all the pain and then pass on my experiences to you guys. So I would say hop on, watch that October 11th presentation from Meta. They'll talk about the new devices coming out, and hopefully they'll reveal everything about Project Cambria, which is the new Meta or the Meta Quest Pro. So not a question. Can't get started. I completely agree. Getting the headset set up now. So cool. Awesome. You made my day. Those are the comments that make me go, this was all worth it. I love that I can give you guys a starting point on this stuff. So thank you, Larry, for that lovely comment. But like I said, I'm here moving forward. Please feel free to reach out to me.
Yeah, seems like people are very content in this one, and thanks for this, explaining it so well.
Awesome.
And so in details. And probably people, please leverage the lancelarsen.com blog site. It seems like all the steps and all being very detailed, maintained over there. So probably leverage that fact for there.
Like I said, I write them for me, so I can remember what I need to do in the future.
Yes. Cool. Then this recording I will post on the event channel also. So please feel free to go through this one, go through all the steps again Lance explained, if you want to try it out. And as Lance told, he's very much available on the site and all that. Please feel free to post questions over there.
Awesome.
Thanks a lot, Lance, and thanks for everyone joining this evening. Please stay tuned. We're gonna have another event on October 19th. We'll have another speaker talking about the cloud. This one we will be like talking about the Unity in cloud using the Alexio. So please tune about that.
Awesome. Have a lovely night, everybody.
Good night, everyone. Thank you.